So I'm going to talk to you today about something that I've entitled From Silent Spring to Silent Night, A Tale of Chosen Men. I hope the title is something that brings people out, if nothing else, just to figure out what the heck the guy's talking about. Before I do that, however, I always do my acknowledgement first. Most people do theirs last. I do the really important stuff first. My first acknowledgement, as always, is to my wife, Catherine Ken, and my son and my daughter for their love and support. I would be nothing without these people in my life. I also want to acknowledge my funding sources. It takes a lot of money to do this stuff. I'm sure you guys know it. And this is also a matter of disclosure. I have been funded by the chemical industry a while ago, but they have since, well, they don't like to hang out with me anymore. I will, however, again, it's not just a matter of disclosure. There are some differences of opinion in the interpretation of my data, and I'll sort of give you what I call words from my former sponsor every now and then, just so you know. Then I want to acknowledge all the students that have been involved. I'm going to talk to you about the last 12 years of my life, and these people have played a very important part in it. They're the ones who actually do the work. And equally important, everybody in blues an undergraduate. I had a wonderful experience as an undergraduate myself, and I've been trying to give that back now that I'm in a place where I can start to do that. And this is my new crew, or fairly recent picture. Another thing that's been very important to me is diversity. And hopefully you can see here we celebrate quite a bit of diversity in our laboratory. And then these are my sort of new crew, I guess. And these are people who've done work that's not published yet, so I won't talk to you so much about it. But nevertheless, I want to acknowledge that they've been involved. And finally, to my family, who I'm going home to see this weekend, my best wishes to my dad, who's actually in surgery as we speak. And again, another place where we celebrate quite a bit of diversity. It's important there as well. And finally, this is dedicated to my grandmother, who passed away in 2005. Luckily for me, she passed on her love of teaching before she herself passed on. And probably more important than she, along with my father, taught me something that you can't learn in graduate school. And that is, if you want to get information across, you don't lecture, you don't teach, you don't give a talk, you simply tell a good story. And that's what I'm going to do today. I'm going to tell you a story. Hopefully one that will make my grandma and my dad proud. My story starts, as you heard, in Columbia, South Carolina, and it starts with a little boy who likes frogs. Period. As long as I can remember, I've been interested in frogs and trying to answer this question. In fact, my proof of that is this book, which my mom sent me when my son was born. She wrote in there, "This was your dad's favorite book." As I always point out, I don't remember the book, but my mama don't lie. She said it was my favorite book. It was my favorite book. This is where it all started. And throughout the talk, as I talk about all these other kinds of things and sequencing genes and measuring hormones, keep in mind that the story is really just about a little boy who likes frogs. And I should have warned you there are going to be some X-ray things. If you're disturbed by it, as I usually tell people, just imagine that the frog on the top has hurt his leg and the other one's helping him get home. It's one of the many fascinating things about these creatures as it were. These guys are wood frogs, and they're doing what you might think they're doing. And the end product is they lay these eggs. So each one of these clumps is about 2,000 eggs laid by a single female. And what's unique about the species is that they lay their eggs in these huge communal clumps. So there's hundreds of females have each laid about 2,000 eggs in these clumps. And what happens in these clumps is a temperature gradient is created where the ones in the middle are warmer. So a few years ago, wasn't quite a little boy then, I was a little older, I got interested in what are the consequences of this behavior. Because the ones in the middle will develop faster. The ones in the middle will metamorphose faster. They'll grow faster. And I also got concerned that perhaps the ones in the middle that are warmer might also have a different sex ratio. So I did some dissection where they metamorphose, some experiments looking at different temperatures. So these are testes, these are ovaries. And my real concern was what are the genetic boundaries? What boundaries do the genes set for the environment to manipulate? What is the interaction between genetics and the environment? So I looked for sex chromosomes, that sex chromosomes might play a role and in the environment might work within those. Now, after all you just heard in the introduction, you must be thinking, boy, the guy sure could use somebody to make some better slides for him. That's because these are slides from my undergraduate honors thesis. These are slides for how many undergraduates in the audience? These are slides from before there was Adobe Photoshop. This is when cut and paste literally meant cut and paste. You had to cut it out, paste it on the page, and make your thesis page like this. This is where it all got started. Here I am at age 19. There's my professor, Bruce Wallman, and I worked for 4 years in Harvard. And here's Laura, who probably went on to do something else, because she doesn't look quite as excited as I am. Being out in the swamp, collecting tadpoles. So we've come a little bit further from a boy who likes frogs who's now learning how to generate hypotheses and test hypotheses and conduct experiments. So that's where we're at now. Another thing that has been with me since I was a child was going to Africa. I remember folding out the maps in National Geographic magazine. I remember watching at 7:30 p.m. every Sunday, Wild Kingdom. And I remember dreaming of being that guy in Africa. And it was truly a dream. I got on a plane for the first time in my life when I went to college. It was completely out of any realm of possibility. In graduate schools, and I went a little bit further, I got that opportunity. And not only did I get the opportunity to go to Africa, National Geographic paid for it. I did a Toyota commercial, I was in the magazine, I was on the show. I literally became that person that I dreamed about as a little boy. I started working in a place called the Arabuko. And one of the exciting things about Africa is no matter where you work, all the places have really cool names. So I worked in the Arabuko. I went there to do something completely different, but I got distracted by this guy, these guys. That's a male, and that's a female of a species called Hyperolius argus. And for a little boy who likes frogs, that's a pretty distracting. I then begin to wonder why the males and females are differently colored on several levels. What are they doing different in their environments? How did they evolve that way? But also, as a graduate student in endocrinology, what role do hormones play in that sexual dimorphism? Males and females look different. So I did some really simple experiments. See, now we had Adobe Photoshop. Look how nice. This is a single individual photographed once a day for 6 days. And we brought some of these guys back and we showed that they all start out green. Doesn't matter if you're male or female. But at sexual maturity, at puberty, the females change color. So the obvious hypothesis was that this was a hormone, same way that in humans, females develop breast at puberty, become estrogen. We hypothesized that this female hormone estrogen is probably important in this frog. So we did a lot of questions I answered simple, and a lot of the answers I answered simple. The implications, I think, are what's gotten the word well known. So simple experiment. We dip some animals in testosterone, nothing happens. You dip them in estrogen, and they change color. Real simple. So we concluded then that estrogen was important in inducing this female typical coloration. Then is where the trouble started. Here's where a little boy who likes frogs gets thrown way off course. This is a species, Hyperolius argus, and I was given this talk up at the University of California, Davis, on February 15th, 1993. I remember the date. It was the day before my son was born. My wife started going into labor during my talk. So we're driving back down the highway to get back to Oakland, where my son was born. And my wife says, "You should pat that." I thought it was the crazy pregnancy hormones talking. I said, "You can't pat the frog." She called her brother and said, "Oh, you can't pat the frog. You're too 40 to be the lawyer." So we did. We called it the Hyperolius argus endocrine screen, or the Hayes test. Here's where things completely get done. First off, here's why you pat the frog. Here's a control. Untreated animals, they're all green. You can raise them by the thousands. They're all green when they come out. This is estradiol. This is the natural estrogen. It doesn't matter if you're a frog, a dog, a cat, a hog, or a human. If you're a female, this hormone circulates in your body at sexual maturity. If you get a methynyl estradiol, this is synthetic estrogen that's used in birth control pills. You change color. If you dip them in DEX, this is a very potent pharmaceutical estrogen, you change color. If you dip them in DDT, which is not a hormone or an estrogen, but it binds to the estrogen receptor, they change color. Here's why you patent the frog. Karen Menendez, an undergraduate, and I screened dozens of compounds. And in every case, every compound that proved to be estrogen in our frog, every compound that caused our frog to change color was also known to promote breast cancer. It's estrogen dependent. So we had a little frog where you could send me a chemical, I dip the frog in it, if it changed color. You could send me a sample of your water. If I dip my frog in cold, you might not want to drink that water. Not only that, we have a frog where if we treat it with tamoxifen, which blocks the estrogen receptor, estrogen doesn't work. This is the #1 treatment at the time for breast cancer. So we had a frog where we could screen pharmaceuticals that might be used to treat breast cancer and screen pharmaceuticals or other chemicals that might promote breast cancer. So that's why you have the frog. So my wife and I, she had an MBA and an MPH. We decided we might set up a little mom and pop shop or a little line on the side or something. I don't know if that's the plan or not. But then, a little boy who likes frogs gets introduced to something called intellectual property. That's where the university says, oh yeah, that's a good idea, and if you don't make money on it, we'll find somebody who will, because we own it. So that's when I get introduced to this company. And I'm a brand new professor at this point, so we're progressing through time. That's when I get introduced to a company who says, we want you to study atrazine. I never heard of atrazine. Here it is. Now if you Google atrazine, you get Tyrone, you Google Tyrone, you get atrazine, we're showing you the carbon bomb. Here's atrazine. It's an herbicide, it's a weed killer. It's been used since 1958 in the US. We use 80 million pounds a year. That's a lot, in case you didn't know. It's used in more than 80 countries, but it's now outlawed in all of Europe. Now this is my fallacious slide. The lawyers keep telling me to have to change this slide because they say it hasn't been banned in all of Europe. It has been denied regulatory approval by the European Union. I don't know what the difference is, but it pisses them off, so I keep this one up. Just the kind of brother I am. So here's what we ended up doing. We ended up, who's ever heard of the African clawed frog xenopus? This is like the lab rat of amphibians, right? It's the model. Who knows why? It's an interesting story. So it turns out the African clawed frog, this one, turns out that it responds to the human pregnancy hormone HCG. That's how you get eggs out of it. You inject it with the human pregnancy hormone, it'll lay eggs. So it turns out somebody discovered this in 1920. By 1940, this was the pregnancy test. If you thought you were pregnant, you would go to the doctor, they would inject some urine, if the frog laid eggs, you'd be either happy or sad, depending on your situation. I tell this story for two reasons to set up what's going to come next. The first one is, I think it's an interesting exercise to wonder, who's the first guy who thought, you know, I wonder what will happen if I inject pee into it. How do you discover that? I've tried to figure out. I have no idea where the idea came from. Tells you the value of curiosity-based science, so I guess. The second reason I tell you the story is part of the explanation of my title. The hormones in my frog hyperolizargus are so similar to the hormones that we use that breast cancer-promoting hormones cause them to change color and us to get breast cancer. The hormone that maintains the pregnancy that's responsible for everybody in this room is so similar to this frog's hormone that it'll make it lay eggs. So as I tell you the story from Silent Spring to Silent Night, you should realize that it's also a tale of toads and men. If I tell you that atrazine interferes with the hormones in frogs, you should start thinking about what atrazine does to the hormones in us. And that's where we'll end up. Starting with the African frog. Although we collected them in San Diego, so I guess technically these are African-American clawed frogs. After the pregnancy test, they just threw them out, and now you can go get them in San Francisco. We discovered that if you take tadpoles of the species and expose them to atrazine in the water, their larynx or their voice box doesn't grow. That's bad news, right? Because the reason that men have deeper voices than women is because of testosterone. That's the same reason that male frogs sing and females don't. It implies that they've been chemically castrated. Not good, but this is your #1 selling product. If they're not making testosterone, then of course you go to the gonads to see what's going on. That's where the testosterone comes from. So these are the kidneys of one of these guys, and this one has testes. That's the male. Oh wait, there's some ovaries. Oh wait, there's another testis. There's a whole party going on there. You don't have to know. There's more ovaries. That's not a judgment call at all. All I'm saying is that frog, unlike you may have learned from Jurassic Park, frogs are not hermaphroditic. Males are males and females are females. There are fish that are naturally hermaphroditic, not frogs. So we set out with a new hypothesis to this, try to explain the demasculinization, the loss of the laryngeal growth, voice box, but also to explain the feminization, the growth of ovaries. Our hypothesis was this. Imagine your noisy neighbor's testicle, not yours. We're going to mess with it. You should make testosterone. This word literally means testicular hormone. That's where the word comes from. It's the male hormone. What atrazine does, we proposed that there was evidence for this, is it turns on aromatase. I want you to remember aromatase, if it's not a word that's familiar to you. It's an enzyme. It's a machinery, if you will, that converts testosterone into estrogen. This word means the generator of estrus. It's the female hormone. So the consequences are, if you're a male, you're demasculinized because your testosterone is being used up. It's a little more complicated than that, but that's good enough. But you're also feminized because now you're making the female hormone, which is fine if you're a female, maybe not so much if you're a male. So we were able to show this in some adults. We looked at blood levels of testosterone. Here's control, males, unexposed males. Here's atrazine-treated males, not so good. Here's control, females. So their testosterone levels when you're exposed to atrazine are no different from a female. At this point, we're coming up for tenure. So we're progressing through time. We call this paper hermaphroditic, demasculinized frogs after exposure to the herbicide atrazine at low ecologically relevant doses. There's some words in there that if you're a chemical manufacturer, you don't really like. Low ecologically relevant. Hermaphroditism. The other thing that makes this significant is, again, I'm coming up for tenure. How many of the undergrads, I know about the other folks, how many of you have heard of PNAS, Proceedings of the National Academy of Sciences? You know what I'm talking about? It's a big deal. In fact, it's such a big deal, I call my mom, because I'm about a month from tenure. I say, Mom, I got it now. Got a paper coming out from PNAS. My mom drops the phone. Picks it up. Son, how do you get a paper cut on your penis? She said, no. I said, P-N-A. She said, you ain't got the spell like that. That's 100% true story. My mom hates it. So a week later, my mom calls me back. But there's a point to it. A week later, my mom calls me back. She says, son, I don't want to hurt your feelings, but how important is that paper you're talking about? I said, Mom, it's going to give me 10. She said, because I went to Barnes & Noble, they never heard of that magazine. But here's the point, I'm telling the story. And we're going to come back to this when we get to the table shows event. We in the ivory tower reward each other for things that mean nothing to 99.99% of the world. My most important paper is in a place that my mom can't even get access to, that nobody who's not in an academic institution can get access to. So you already saw it. Here's my new most important paper because my mom can buy it at Barnes & Noble. And we're going to come back to why that's important. The other thing that's important, in addition, so I got tenure, we're all right now, is 4 black men and a Latina co-authored this paper. It's part of a record for the National Academy. As important as it was, though, there were a few things we didn't know. We didn't know if the hermaphrodites were males with ovaries or females with testicles. Sounds like an easy question to answer, except that, as I found out in my undergraduate, frogs don't have sex chromosomes, so we didn't know who was who. We had a good idea, because if we did one of these treatments, we'd get 50% females, 30% males, 20% hermaphrodites. So we kind of knew it was males turning to females, but we couldn't prove it. We also didn't know what happens when they become adults. We only looked at the little tiny metamorphs. Sounds like an easy question to answer, right? Takes these guys about 4 years to grow up, maybe 5. So you got to get an undergraduate or even a graduate student, okay, I have a project for you, and maybe by the time you graduate, you might have data. In fact, it was worse than that. It took 8 years. But I was in no hurry. I had 10 years. Here's the final answer. We're going to go back to PNAS in a minute. They wouldn't put it, they published the picture, but they wouldn't put it on the cover. They said people weren't ready. By the time the paper came out, we had a molecular marker, DMW. We could tell genetic females apart from males with a little PCR. So sometimes we do something for you. And that guy who looks like he's smiling with the hurt leg, he's a male. That's his brother. Turns out 10% of these guys completely turn into females. They lay eggs, everything. In fact, how many times do you hear this one? He is a grandmother now. So I could have published this in a high-profile place. Males turning into females. People want to see that, I think. Or maybe not see it, but you know what I mean. But I had tenure, I was in no hurry. I said, I want to see what happened to the males that didn't turn into females, that were exposed. I want to see if those males can reproduce. The problem is that frogs reproduce in the spring, and apparently so do undergraduates. So there's all kinds of pool party, they all want to go away for something. And so you got to be tricky, especially when you work with undergraduates. So I said, look, how about in 2008 when we did this, I have a spring break pool party for you and we get some science done. You stay here. Well, you guys would do that, right? Yeah? Okay. Went something like this. So this is our experimental apparatus right here. So what we did was we took these animals that we were raising up and we put 4 females in one of these pools. And then we put 4 males and then 4 atrazine-treated males and just see what happened. We matched them for size. Everybody was a virgin. Experience didn't matter. So we could only test each animal once. And here's how you do that. You put them in there, okay? And then you come back the next morning and see, you say, oh, that guy, he did okay. Real simple. And when you do that, here's what you find out. Controls almost always win. The atrazine-treated males, matched for size, only 2 ever got the female. Now, we don't know. Well, let me show you this first. First, let's look at what's going on with the hormones, because I'm an endocrinologist. I can't just look. I got to suck blood out and measure something. The testosterone levels are much higher in the controls. What's more important is if you look at the individual data, look at who made the love connection on each side. There's almost a cutoff. What we don't know about to say is we don't know if females just don't like these guys or if these guys beat them all up to get the females. That we don't, all we know is who's hooked up the next one. I probably could have published that. I was in no hurry, though, because I had tenure. I said, there's still a little information we can get. So then we did what I call the Motel 6 experiment. In this case, we just got them a room. No competition. We got them a room, put an atrazine male there, the female, a control there. There's blinders so they can't see what's happening next door. Everybody had to practice. And the assay, the test here was we just looked at how many eggs got fertilized after a night of romance. Real complicated assays. Each female lays about 2,000 eggs, and the way that you determine the fertility is you count how many hatch. So there's an undergraduate sitting in lab going 1, 2, 3, 4. When you do that, simple questions, simple answers. Controls fertilize about 85% of the eggs. Atrazine males about 15%. For 2 reasons. One, they don't even try. No competition. They sit there and they watch the females lay eggs. The second reason is the following. Like any scientist, I like p-values. But what I like more than p-values is when I can see a difference. I don't want the p-value to tell me there's a difference. I want the p-value to prove to you there's a difference. I like to see it. You can see the difference there, can't you? That's a control. That's an atrazine. And these are their testes sliced up under the microscope. And what you're looking at is, here's a testicular tubule that's all full of sperm. Here's a testicular tubule that's got a little cellular debris and it's mostly empty. So even if they have enough testosterone to show the behavior, they don't have enough testosterone to support sperm. So even if they copulate, show the behavior with the female, these guys just can't cut it. Back to PNAS. Atrazine induces complete feminization and chemical castration in male African clawed frogs. Also words that you don't like. If your company makes the chemical, but again, that's just the kind of brother I am. More importantly, there's 1, 2, 3, 4, 5, 6 undergraduates who gave up their spring break pool party and are in co-authorship on our second PNAS paper. Oh boy. Now I've got this student named Mai. Mai's been working with me for a long time. And we decided, again, we wanted to look at that genetic component, if it was there. So we took a bunch of lines, a bunch of families, right, different parents, and we raised up all these males, and we said, let's see if some families are more sensitive to atrazine than others. That makes sense, right? Same as why do some families get cancer and some families don't. We wanted to see what the genetic component was. And we had these males in these tubs, 40 males per tub, and Mai would come up in the morning and say, it takes me a long time to clean the tubs because I have to pull them apart. I said, what do you mean you have to pull them apart? They're all males. And she showed me this. And she showed me this, look at that. They're like, hey, can we get him in there? I never seen anything like this before. Only happening in the atrazine. Well, that's not true. Occasionally there's a random hookup in the control. This is, you can come to my lab any day of the week and I can open an atrazine tank and show you a party going on like this. So you can guess what's coming now. So my first hypothesis was that they've never seen females. They've been locked in these tanks with males all their life. My first hypothesis was that it was big males overpowering little males in that type of situation. The answer is no. If you look at who's on top and who's on the bottom, the ones on the bottom are always bigger. Which is interesting because females are usually bigger in the species. What's more is the ones on the bottom are always the same individuals. I pulled the slide out. You can take the ones on the bottom out of the tank, the behavior goes away. You can put those in the control tank, the behavior comes. You can put them back. So the ones on the bottom are driving the behavior. It's not random hookups. What's more is the ones on the bottom typically have lower testosterone. These are the ones they're paired with. But more importantly, the ones on the bottom have estrogen levels that look like female. So they're male, but they think and behave as if they're female. You know, for other types of sexual orientation, all kinds of complications. Do you court, do this? For a frog, it's do I get on the top or the bottom? That's the orientation. It's real straightforward. What's more is, some of these males are partially feminized. So their testes, these are oviducts. That's the equivalent of a man with a uterus. So we have a range of animals where some males are not affected at all, some are completely feminized, some are simply demasculinized, others have their behavior and some parts feminized, but aren't completely feminized. And we're working on what controls that level of sensitivity now. So now I'm an associate professor. We're still moving forward in time. And so now the question I wanted to ask is this some weird thing that only happens in African clawed frogs, or is it a general phenomenon that you'd be concerned about in amphibians? So we started working on a North American leopard frog, and we showed the following. This is from a paper we published in Nature. So here's testes, and you see all these, I call it junk in the trunk. Those are eggs that are bursting through the surface of this male's testes. Now, pardon my language, about pissed off a few people in my field. In addition to the chemical company, the EPA don't like me too much either. So I sent, anybody from the EPA here? Always ask, there's always right. So I actually sent this to the EPA because they were reviewing atrazine. So I sent the data before it was published in Nature, which is breaking a rule in Nature, as you know. And I said, look at what happens to North American leopard frogs exposed to 0.1 micrograms per liter estrogen. The EPA wrote me back. They said, dear Dr. Hayes, thank you for the information. While it is interesting, we don't view it as an effect, an observation that would trigger regulation of the kidney. I talked to the fellows for a minute. My wife tells me there is nothing more painful in life than childbirth. I would say, based on the G.I. Joe Kung Fu grip she had on my hand when my son was born, I'm going to give her that. But fellas, don't you think that a dozen chicken eggs in your testicle would fall somewhere in the top 5? Just somewhere. The EPA says, no, it's not an adverse effect. We'll let them carry on. They're the experts, I guess. The other reason we work with the North American leopard frog is we wanted to go out to the field in the U.S., where there's not elephants and hippos and stuff, and ask, do effects occur in the wild, or is this just a laboratory artifact? First of all, let me give you an idea of some numbers. Let me show you what we're talking about. We use 0.1 parts per billion, 0.1 micrograms per liter. That's about 1/1000th of a grain of salt in a liter to produce the effects I just showed you. The package of atrazine recommends application of 2.9 to 29 million parts per billion. I'll do the math. That's 290 million times higher than we're using in the laboratory. If you go through the literature, here's the minimum and maximum in agriculture runoff, temporary pools, permanent water, precipitation. Here's what we're using in the lab. Here's all the habitats at risk. There is enough atrazine in rainwater to chemically castrate and feminize frogs. Goes up on the dust, travels in the clouds, can travel over 1,000 miles, comes down. They can measure it in Minnesota from when they applied in Kansas. What's more is, here's the drinking water standard, 30 times higher than we know to be biologically active. When I first started my experiments, Environmental Health and Safety wrote me, he said, we're concerned. What are you going to do with the wastewater after your experiments? I said, I want to take it home and drink it, because it's guaranteed to have 30 times less than. I thought it was funny. They don't play around, though. They were upset about that. Here's the bottom line. Here's kidneys, here's testes. Imagine I'm slicing up a salami. That's what it looks like under the microscope. The color's different because of the stain we use. And if I blow this section up, those are eggs. Those are testicular oocytes instead of sperm. And this is now from the field, right there. Oops, no, right there. And we did a study where we looked at atrazine across the country. We controlled for latitude. I'm just making that up. That's Highway I-80, and we would go into a HERT meeting in Indiana, and we collected samples and got a Nature paper. See, that's some fuel efficiency. It turns out every place we found atrazine, we found hermaphrodites. That's just a correlation, except that we can reproduce the effect in the laboratory, except that we can take animals from this site and raise them in the lab and show that they don't naturally develop this way unless you give them atrazine. So we had a combination of experimental data and correlational field data that got us, again, a Nature paper and an environmental health perspective paper. Now, the next thing we wanted to do is we wanted to put this in a broader context, because there's more than just atrazine out there. If you fly across the country, most of it looks like this. This is actually in Nebraska. We work at a field that's right about there. We did an experiment, though, in California on the Salinas River. Salinas River runs south to north. And who ate something from Salinas today? You don't know it, but I guarantee you did. 85% of the country's lettuce comes from Salinas. This is only like a 2-hour drive. 85%. Very intense agriculture. Here's where all the farms are. So the river starts out clean, gets more and more contaminated. If you go down here, here's where rich people in Monterey get their water from. That's a protected watershed. If you go to Toscadero, there's almost no water there. This is a 100-degree, 1.5-inch pool in the river with about 3,000 tadpoles dying in it. But no pesticides. If you go down here, the water's back, but 100% of its agricultural runoff from your food. 100%. Here's what tadpoles look like. Same age, same stage, same species, collected on the same day. The only difference between this one and this one is that this one lives downstream of water that runs off of our food. Food that when you drive by the field has a warning, pellagra, poison, do not enter sign on it, and somehow a few hours later in your grocery store, it's supposed to be okay. Here's Salinas, surrounded by agriculture. 85% of your lettuce. Now I want to share with you just for a minute the value of a liberal arts education. I want to read to you from John Steinbeck's East of Eden passage I came across. Salinas, he wrote, was surrounded and penetrated with swamps with tool-filled ponds, and every pond spawned thousands of frogs. With the evening, the air was so full of their song that it was a kind of roaring silence. It was a veil, a background, and its sudden disappearance, as after a clap of thunder, was a shocking thing. It is possible if in the night the frog sound should have stopped, everyone in Salinas would have awakened feeling that there was a great noise. In their millions, the frog song seemed to have a beat and a cadence, and perhaps it is the ear's function to do this, just as it is the eye's business to make the stars twinkle. Here's what Salinas sounds like now. In the 5 years that we've been working there, we haven't heard a single native frog call. The tadpoles, we believe, are washing from downstream in Margarita. Not a single frog. And that's not a piece of scientific literature. You never know where you're going to learn something. But the frog sound, the call there, was so important and such a part of that landscape that a literary artist dedicated a page to describing that sound that's now gone. Not a piece of scientific literature. I can't show you the data in a bar graph of how many frogs used to be there, but I think there's pretty good darn evidence that in 1952, 6 years before we introduced atrazine and the pesticide-dependent agriculture, they were there. I can't tell you that the 70% decline in amphibians, animals that have been here since the dinosaurs, the decline of 70% of all species, I can't tell you it's all due to pesticides, but I can tell you that environmental pollutants, and it's from a paper I published in my graduate student, has an incredible interactive effect with other factors that lead to amphibian decline, such as pathogens, atmospheric change, habitat modification, and invasive species. An incredible, important interactive effect. My former sponsor feels a little different. I can't bear to read it out loud. I'll let you enjoy it all on your own. This is Lake Nabugabu. Again, anytime you work in Africa, you get to see a cool name. In Uganda. And I show this to transition to the last little section of my talk. This, I believe, is arrowroot. And all that water is runoff that's also collected as the sole source of drinking, cooking, bathing water for a village that's somewhere back here. I find this telling because I think if I told the men in that village that the frogs in that water had eggs in their testes and their immune system didn't work and they couldn't grow, I think that these people without fancy universities around them, without fancy environmental protection agencies, would see the connection between environmental health and public health in a way that we can't seem to understand anymore. See, in my village, I live somewhere here, my water just comes from there, but I don't have to get a can and go get it. It comes out of a faucet, and I make some huge assumptions that there's nothing in it that could impact me adversely. I don't think that's true. So I call this From Silent Spring to Silent Night, because in much the same way that Rachel Carson taught, collected data, that the decline in birds primarily due to pesticides used in agriculture, and our silent spring was a warning to us, I believe that our new canary in the coal mine, frogs, and our pending silent night, our silent night that's already here, that's approaching for over 70% of all species globally, it's also telling us something about ourselves. A colleague of mine wrote, in ecoepidemiology, the occurrence of an association in more than one species and species population is very strong evidence for causation. I've talked to you about more than one population, more than one species, more than one genera, multiple families of frogs. But what I'm going to tell you now is that similar effects have been shown in fish, reptiles, birds, and mammals, including human cell lines and human epidemiology. Now, sponsors, after they made big efforts to discredit my work, attacked a few documentaries I made, and then they revealed, this is from some news media, House agenda investigated the press and shaped the news about controversial weed killer atrazine. They just lost a court case that required them to open up all their notes. And can you believe that the fools actually wrote down the stuff that they did to me? They actually wrote down, have his phone, hack his email. They paid, I'm not joking, they wrote it down. This public, you go get it. They paid somebody $10,000 to develop my psychological profile to prove that I'm crazy. You ain't got to pay nobody $10,000 to find out if I'm crazy or not. You can just ask anybody who's known me and they'll tell you that I'm crazy. But that's got nothing to do with my science. The other thing is foolish. I wish they paid me the $10,000. Because what is the possible outcome? That's how desperate they were. There are two possible outcomes in this endeavor. One is they come back and they say, no, he's not crazy. He just pissed off a black guy. Because see, sometimes people get those two things confused. We're an emotional people. The second one is you come back and say, oh yeah, he's crazy. Now you've got to reconcile yourself with the fact that you got your butt kicked by a crazy guy. So there's no positive outcome in the endeavor. At any rate, what I did is I decided that I'm going to approach it this way. Instead of writing a review paper to show that this is an effect that occurs across sciences, I emailed everybody in the world, this is only a partial list, who's ever published on atrazine. I said, hey, let's all write a paper together. Crazy. And even Canadian people don't know how to write good English. Try editing something. We published one of them. There's 22 of us, I think, from 12 countries here. I managed to introduce the word gonatotoxin. That really upset me. But again, that's just kind of where I am. Here's what we found out. Remember my frogs? You give them atrazine, there's no sperm in the testis. Here's fish. This is a guy from Belgium. This is reptiles. This is actually, I don't know if it's a guy. I've never met him. In Argentina, working on reptiles, big alligator-like thing, caiman. Look, looks just like my frogs. Here's rats. This was done in Nigeria and Croatia. Sperm in the testes, you give a rat atrazine, there's no sperm. And here's a guy in Pakistan, you give quail atrazine, sperm goes away, there's no sperm. So it's not just frogs. I'm still crazy. But my science is in line with science from around the world, showing similar things in every vertebrate class with good examples. What's more is it because testosterone goes down that you don't have the sperm, like I proposed? Here's fish. This is a guy in England, published this. Here's my frogs. Here's rats. So again, across vertebrate classes, atrazine causes testosterone to go down and is associated with an absence or a severe decrease in sperm production. In humans, here's Shauna Swan, colleague and co-author. She measured atrazine in the urine of men in Columbia, Missouri, and she showed that there's a significant correlation between atrazine in your urine and low sperm count, inability to get your wife pregnant. P-value, like p-value, 0.009, and gee, look at that. If you have 0.1 parts per billion atrazine in your urine, you have low sperm count. It's just a correlation. Well, it's the same thing we've seen experimentally in fish, frogs, birds, reptiles, and rats. What's more is, I squashed that down, because I know how to work PowerPoint. But look at this. This is California, and now I'm going to squash it down again. These aren't my data. This is published in the literature. 2,400 parts per billion in applicators. That's 24,000 times the atrazine that we know is associated with low fertility in Columbia, Missouri. That's 24,000 times the atrazine that we use in the laboratory to chemically castrate frogs. One of these guys can pee in a bucket. I got diluted 24,000 times and use the atrazine in their urine to chemically castrate and feminize 24,000 buckets of 30 tadpoles each. But we know nothing about the health care of these men, because they're 90% Latino. And in addition to atrazine, they're exposed to chemicals like chlorpicrin, which was originally developed as a nerve gas in World War II, and in many cases, the life expectancies of these men is 50. Now, a little boy who likes frogs is throwing out terms like environmental justice and environmental racism. This is California, where I live now. Turns out California, I'll give you a few California facts. Turns out if we were our own country, actually I'm not sure where our standing is now, but at the time I made this slide, we'd be the 5th largest economy in the world. If we were our own country, California, we would be the 5th richest country in the world. Because of agriculture. 1 in 10 jobs are in agriculture. 30% of the land is in agriculture. We produce 350 agricultural products. Are you ready for this one? 50% of the U.S.'s food comes from California. 50%. Half of the U.S.'s food. What is our population now? 300 million or something? Half of that food comes from California. We use more pesticides than any other state, and 90% of the workers are Hispanic. Now, if I plot on here, 30%, those are the top 10 agricultural counties in California. These are the counties that make us the 5th largest economy in the world. Yeah? Where do you think the 30 poorest towns are in California? So the people who make us the 5th largest economy in the world are the targets, indirectly, of chemicals that we know are associated with poor health outcomes. Little boy who likes frogs now is talking about environmental justice and environmental racism. There's other perspectives. On the other half of the equation, does atrazine turn on aromatase, which I asked you to remember? And does this estrogen introduce vitellogenesis, that's making egg yolk, and oogenesis, that's making eggs? Well, I told you about frogs already. I like this one because it looks like I love it. Those are eggs in the testes. That's fish. USGS published that. That's reptiles. Down in Canada published that. So ectotherms in general is showing an effect that we described earlier. So it's not just some crazy guy in Berkeley, and it's not just frogs. Now in mammals, you're not going to grow eggs in your testes. I heard somebody say that at lunch. You're not going to grow eggs in your testes, but aromatase is involved in mammary tumors and prostate cancer. The #1 and and number 2 cancer in males and females. With regards to prostate cancer, a study from their own factory in San Gabriel, Louisiana showed that there's an 8.4-fold increase in prostate cancer in their workers in their factory that bag the atrazine. That's compared to men who work in the factory but don't do the bagging. And it's a community that's 80% black, African American. I'll tell you why I point that out in a minute. With regards to breast cancer, with a p-value of 0.0001, a study showed that women whose well water is contaminated with atrazine are more likely to develop breast cancer as compared to women who live in the same community but don't drink the well water. Now that's just a correlation. That's just a correlation. But if you look at rats, you give them atrazine, testosterone goes down. There's a concomitant increase in estrogen, just like we've shown in mice, just like we've shown in frogs, just like they've shown in reptiles, just like they've shown in birds. These are mammals. And what's more is their own company has shown that if you give rats atrazine, this is peer-reviewed and published, there's a significant increase in the incidence of mammary tumors that are estrogen dependent. So the human stuff is just a correlation. But the rat stuff sure suggests causation. What's more is if you look at human cell line, and we published this, so did they. If you take a human adrenal carcinoma, it doesn't express aromatase. Give it atrazine, it starts expressing aromatase and making estrogen. Just like a fish, just like a frog, just like a reptile, just like a bird, just like a rat. The human cell line. So I went to visit. I said, hey, where's Tyrone? Can I come in? They have a pipe that flows right into the Mississippi River. 1.2 million pounds of atrazine flow into the Gulf of Mexico every year. And much of the community looks like this. The reason I mention that is 80% African American is the following. These are the top 13 cancers you're going to get in the U.S. And red now, 11 of the 13 are the ones that you're more likely to get if you're black or risk factor. What you're looking at now is relative mortality. If you're white, if you're Caucasian, there's your normalized death rate. Here's your likelihood of dying from these same cancers if you're black, if you're African American. It's a risk factor. Does that mean that there's a biological difference? Or does that mean that if you're black, and I can show you the same data for Hispanic, these are corrected for socioeconomic status and access to health care. Does that mean if you're a minority, you're more likely to live in and more likely to work in areas that expose us to the crap that we know is associated with poor health outcomes? If I tell you that you are more likely to get breast cancer if your mother had breast cancer, does that mean that you have inherited something genetically, or that you were exposed to the same crap that your mom was exposed to? You can't even answer that question. For breast cancer, the #1 cancer in women, you know how many cell lines are available from minority women, from black or Hispanic women? 0. So you can't even start to ask what the differences in the biology is. You can't even start to ask about the efficacy of the breast cancer treatment drugs and if they differ between the races, because we don't even have a cell line characterized to compare them to. I'm just a little boy that likes frogs.
How about hero cells?
Those are a stem cell, not a stem cell line. They're not a cell line from an endocrine active or responsive cancer. It'll come to me in a minute. They're fibroblasts, I think.
Uterine.
Is it uterine? So here's what's happening. Little boy who likes frogs, I believe that this aquatic organism has taught me something about this. I believe the same hormone, I don't have to believe, it's a fact, the same hormones that control this amphibian's early development control this mammal's early development. And I believe that my frog trapped in an aquarium, contaminated, or trapped in a pond, contaminated, is no different from this guy, trapped in a contaminated environment. Because the placenta was not designed to keep these chemicals out. The data now show that we are exposed to over 300 synthetic chemicals before we leave the womb. 300, most of which we know nothing about. To give you an idea of that potential impact, this is from a graduate student of mine who's shown that if you give a breast cancer cell atrazine, it starts expressing aromatase. It upregulates aromatase. That's bad news. Think about breast cancer for a second. It's estrogen dependent. Probably all of them start on estrogen dependent. When do most women get breast cancer? After menopause. When your blood levels of estrogen are lower than they've ever been in your life. Does that make any sense? For two reasons. One is breast cancer seems to be most dependent on your lifetime exposure to estrogen, including in utero exposure. That chemical I showed earlier, DES, you're more likely to get breast cancer if your mom took that when you were pregnant. So early exposure is important. What's also important is when these cells get damaged in the breast, they express aromatase. They make their own estrogen. So even though your estrogen levels in your blood are low, locally it's being made, and that's what causes those damaged cells to turn into these breast tumors. That local aromatase is so important that you know what the #1 treatment for breast cancer is right now? #1, letrozole. It knocks out aromatase, it decreases estrogen, so that your damaged cells don't turn into a tumor. How much sense does that make when the #1 contaminant of drinking water, groundwater and surface water, does exactly the opposite, is correlated with breast cancer incidence, and promotes breast cancer in rats? Here's where I really got in trouble. Novartis Oncology offers treatments for cancers that range from breast cancer. But the same company that gives us 80 million pounds of atrazine, which turns on aromatase, makes letrozole, which blocks aromatase. The same company that if you go to their webpage will say, we're going to cure cancer by knocking out aromatase, will tell you, Tyrone's crazy. Atrazine turning on aromatase has nothing to do with breast cancer. I wrote a paper called The One-Stop Shop Chemical Causes and Cures for Breast Cancer. And they wrote a letter to my dean. I don't know why. I told my daddy lived in South Carolina. They're always writing letters to my dean. If they want something to happen, they need to tell my daddy to talk to me, because I got tenure. My dean can't do nothing. So atrazine has been shown, if you don't care about frogs, to cause prostate and mammary cancer in rats. I didn't have time to talk about all the data. It's not mine. It's published. It causes immune failure. We've also shown this in amphibians. Been shown in fish, in rats. It causes neural damage when it's exposed in utero. What I think is more significant, it's all significant, but what moves me more is the following. An EPA laboratory, they're separate from the regulatory people, showed that if you give a rat atrazine, they tend to abort because of the hormone balance it creates. A second EPA laboratory showed and published, you can look it up, that of those that don't abort, the sons are born with prostate disease. They're born with the prostate of an old man. A third EPA laboratory showed that of the rats that don't abort, the daughters are born with impaired mammary development so that their offspring have retarded growth and development. That's a lot for a little boy who likes frogs to take in. This rat is affected by atrazine that its grandmother was exposed to. This rat never saw atrazine. This rat is affected by atrazine that its grandmother was exposed to. So when I think about my little girl, she's big now, 17, when I think about the idea that my daughter's daughter, that my granddaughter's daughter could be affected by chemicals that we're using today. My granddaughter, your granddaughter's granddaughter, will potentially be affected, exposed to chemicals that we're using today. It moves me well beyond just a little boy who likes frogs. This paper just came out last year. Their conclusion was that maternal exposure to surface water atrazine is associated with fetal gastroparesis. This is published by the Center for Disease Control. One of my former undergraduates is working on this problem now. It's just a correlation. This paper just came out 2 months ago. Maternal exposure to a common herbicide atrazine is associated with a nearly 2-fold higher risk of having offspring with a rare birth defect of the nasal cavity, choanal atresia. It's just a correlation. My advisor told me, don't be an advocate, he said. Let the science speak for itself. And I think there was a time when that might have been appropriate. But how can I let the science speak for itself when these guys are saying Syngenta assumes no obligation to update forward-looking statements to reflect actual results? Pardon my language, first off, who said shit like that? When the EPA says the ultimate decision is much bigger than science, it weighs in public opinion, now we come back to the kids' book. If we as academics are publishing our work in places that the public has no access to, how is the public supposed to have an informed opinion when our government agency, the EPA, is counting on them? Because the ultimate decision is much bigger than science. So I've crossed the line. In any kind of way that you want to interpret that. I sort of maintained a web page. It was just pointed out I need to update it so that my mom can get access to those papers that she otherwise doesn't have access to with sort of my summary in the best language that I can to make it available. I've helped a group of college kids from Illinois start a Facebook page. I've helped several people with petitions to ban atrazine. I helped Keith Ellison write a bill to ban atrazine in U.S. Congress. I helped these lawyers. They didn't get a dime. Squeezed $105 million out of Syngenta to clean up water supplies across the country. And I've been in a number of documentaries. The most recent one, Last Call of Oasis, where I had to be with Eric Brockovich, which I felt was an honor. I've been faced, though, with some animosity. They call me an environmentalist. And so I'm big on words. I wanted to make sure, before I got upset, what they were calling me. So I looked it up. And it says, any person who advocates or works to protect the air, water, animals, plants, and other natural resources from pollution or its effects. And I thought, what person would think that that was an insult? It says more about them than it does about me. But here's the one that got me. They wrote the following in a press release. They said, Hayes, biologist turned activist. I turned. And I was sure that was an insult. But I went to the dictionary because I was taught to be informed first. I looked up activist, and it says one that advocates or practices activism. But that wasn't very useful. So I looked up activism. And under activism, it said a doctrine of practices that emphasizes vigorous action. And my first thought was, I don't mind being vigorous or active. But just in case, I looked up vigorous, because you never know, they might be sneaking something on you. Vigorous says possessing vigor, full of physical or mental strength or active force. And I thought, I don't mind that either, but there's got to be an insult in there somewhere. So I looked up active force. Activist says characterized by action rather than by contemplation or speculation. And I thought, that kind of sounds like a scientist to me. And under force, it says a strength or energy, especially of an exceptional degree, active power. Here I thought they were trying to insult me. I think I'll take that as a compliment. As a result, I follow a different philosophy than what I was taught from my advisor. Science can't speak for itself. In fact, someone said those who have the privilege to know have the duty to act. I wasn't privileged. I grew up in a low-income neighborhood and all that. I've been to Harvard, I've been to Berkeley. I'm pretty privileged, so all of you to be here. So not only can you be a biologist and an activist, if you have the privilege to know, you have a duty to act. I accept that duty. This guy said that, in case you Sure, I'll take questions. And thank you again for the invitation. Thank you for coming and for your attention. But yes, I will take questions, comments, or corrects. Yes.
I just want to point out one other impact of atrazine. That said, it causes corals to bleach and
Yes.
may be implicated in a lot of the problems that we see in the degradation of coral reefs before the Keys, Gulf of Mexico, and the Caribbean.
There's a lot of direct impacts. Well, because we do all of our experiments blind in the lab, for example. But when we do long-term experiments, the students always figure out the control because some of the tanks never grow out.
So,
I mean,
what's the impact on the ocean of this compound?
I don't know that anybody's looked. Well, no, I take that back. There are people looking.
You know, large amount of it goes down the Mississippi River.
Yes. Well, both what's dumped into the river by the company was on the river, but also as the North Platte and the Missouri all feed into the Mississippi and it comes down as well. Both of those are well, atrazine and other things. Again, that's the only one we're looking at. Who knows what all the other things are as well. Yes?
When you were talking about how the females it would cause them to abort, were you talking about letrozole or the atrazine that's causing them to do that?
Atrazine. So what atrazine does is, so pregnancy, very much on the delicate balance between progesterone, estrogen, testosterone. So when atrazine's upsetting that balance, progesterone means progestational hormone, right? So that's the hormone that you want to be in excess during pregnancy. When atrazine's upsetting that balance, then that will cause you to, and there's similar associations in humans with preterm birth and small for, what is it called? Small for gestational age birth in humans as well. Again, those are correlations, but you see the same kinds of effects in rodent models. Yes?
All right, so given that these chemicals are all in the groundwater, is organic food safe? Well, everything's cursed, right?
So the organic food issue is one that, yes and no. So, I mean, well, atrazine's in the water. So you're not going to get atrazine, for example, in your corn, whether it's organic or not. As far as I know, there's no atrazine in your corn or your sugar cane or wherever it's supplied. It's water contamination that you want to be concerned with. There are other pesticides that are on the surface that you can wash off, and there are other pesticides that are inside the actual fruit or vegetable or meat that you can't simply wash off. So when you consider the whole, the answer is difficult. Organic food doesn't mean pesticide-free. It doesn't even mean that pesticides haven't been used. It depends on the, I think it depends on the state. However, I support local and organic produce because for political and socioeconomic reasons that will hopefully drive a difference in how we do agriculture. But I don't know. Between me and you, I don't know if it's safer. Stuff I grow in my backyard is pretty good. Yes?
We use 80 million pounds a year. How much do we export?
How much? Oh, we're not export. Oh, that's the point I forgot to make. The whole point of the European Union banning it is that that's where the company is. So, well, it's not. It's in Switzerland. So we're not exporting it. It's actually being exported to us. Yeah, we make it here locally, so it's made in San Gabriel, Louisiana. But it's not an American company. It's a European company. That I forgot. That was my point about them arguing about whether or not it's been outlawed or denied regulatory approval. The point is, they don't use it at all.
How much is used worldwide?
I think it's not much more than that. The U.S. uses most. It's like DDT, for example. When DDT was being used, a fifth of the world's DDT was used in Central Valley, California. So worldwide, it's not that. I don't want to make up a number because I don't know it, but it's not much more. It's not much bigger than 80. The other big users are probably Australia, but they mostly use it on forestry. Canada uses it, Mexico, and those are probably the biggest.
Is it all exported?
It's made locally, but it's a European company, so we make it in San Gabriel, Louisiana. So they have a plant, and I think that's all they make it from there. The different plants make different pesticides. Yes?
So you're saying that this massive amounts of chemical pesticides have been used in the same place for 50 years. How come there are any insects left to kill?
Well, in this case, it's an herbicide.
Or herbicide? I mean,
And-
how come there are any weeds left to kill?
And I can address that in two personal observations. That field I showed, well, there are two answers to your question. But one is that field I showed you, the 413 in Nebraska. They stopped using that field. I want to believe in part because we published on it. I've been back there for 5 years. Nothing grows on it. I've been working with a group in Tasmania trying to get rid of atrazine, and they have a site where a plane crashed that still hadn't emptied its, whatever it's called, cargo of atrazine. Nothing's complete desert. Everything's dead. The answer to your question, though, where they use it for 50 years, there are over 80 species of weeds that have become resistant to atrazine. Same reason we still have mosquitoes when we're using DDT. When you use something so intensely like that, you drive the selection for pesticide-resistant organisms. Yes?
What's the status of the bill that you helped write?
Nothing. I mean, this is one of those complicated issues because it's, one, you'll read on some websites that like the Center for whatever, Center for Hate Tyrone or something like that they're feeding the world. Has nothing to do with feeding the world. 20% of the world dies of starvation. We eat less than 2% of the corn that we grow. Atrazine increases corn yield by 1.2%. More than half the corn now goes to ethanol production, which they produce by burning coal. So here's why nothing's happening. If you're running for president, where's the first presidential caucus? What do they grow in Iowa? You ain't gonna go there talking about, I'm gonna appoint an EPA person who's gonna ban the #1 chemical used in the #1 product that is the basis of your economy. So maybe this term we'll get something done. It's been reintroduced, I think, 3 times. It's just, Minnesota tried for about 5 years. before Keith Ellison was elected to U.S. Congress. And it's all about lobbying. It doesn't move. Yes?
Are there any remediation methods that have been suggested or being tested for atrazine?
I've heard, there's a paper out. One, it can be around for up to 10 years. France has banned it. It's stable in the aquifers. I've read a paper and I've heard about a bacteria that metabolizes it. And I know that there are people, oh, the guy's name's escaping me now. I know that there are people who are working on green chemistry, working on molecules that will actually destroy harmful molecules. And you guys have already heard me talk about chemistry. That's as much as I can explain to you. Not my thing. But I know that there are people working on it. But otherwise, that's all I've ever heard. Yes?
What's the newest news on the national regulations of atrazine? Is anything happening with the EPA? Where does it stand?
So the question is, what's the news on national regulation? One, people should realize the EPA has never really banned a pesticide. They allow them to be voluntarily taken off the market. So there's not very much over there. The EPA opened up 3 unprecedented reviews for atrazine, and no report has been produced yet. My guess is they were holding that to after a new term was here or not. So I don't know. I testified at the last one. The last EPA hearing I was at, there was no argument about the science. It was really like, okay, yeah, these things happen, but is that a big enough harmful effect that it would offset the potential economic loss? Literally, that was the discussion. That's all public. You can go home, I mean, you can go online and read the transcript. So there wasn't any real argument about the science at all, especially about the wildlife stuff. Yes?
So economically, are there feasible alternatives to atrazine for growing things like corn and sugar?
Well, that's a tough question. Europe got rid of it, and their economy didn't, well, at least didn't collapse because of loss of atrazine. The problem is, Europe got rid of it, and then they produced another chemical that's one methyl group away. Oh, that's as much chemistry as I know. One methyl group that's not registered in the U.S. So they're ready to go with the next one. In fact, that's why Keith Ellison's bill says to ban all trizine herbicides. So it actually asks for a complete ban of all. And there's been at least 2 economic analyses. There's a guy at Tufts who's like an agroeconomist who's written about atrazine and what would happen if we got rid of it. Things like that. I know he's working on another one. Yes?
How about Roundup Ready? How about atrazine ready? You think that that's a possibility?
So the question is, what about Roundup Ready versus atrazine ready? The reason that atrazine is so big on corn is that corn is naturally resistant. Any monocot, grasses and things, they have something called a glutathione reaction. So the atrazine comes through the roots and it's attacked and dispersed. That's why you don't get it in corn. And other weeds can't do that. So it's naturally atrazine ready. Yes?
You talked about atrazine being in like more in the west, in California and out in the western part. Do we see the effects of atrazine in groundwater in South Carolina?
One, because it's mostly used on corn. You might have seen that big red splotch in the Midwest, which, I realized I almost made a red state joke. So those red states that are using atrazine in the Midwest, the use in California, if you look where the spots are, it's not in those same counties with agriculture. The use in California is on forestry. So when they chop down all the trees, they spray a big bolus of atrazine so that nothing grows back when they replant. So that's mostly not on the corn. The difference in California is we grow food. The Midwest grows corn, which again we don't eat. So most of it's in the Midwest, but there are 2 papers that I know of. And help me if you guys know. There are at least 2 papers on atrazine in South Carolina, I think in this area, in Charleston. And if you're interested, you can email me and I'll turn you on to them. But there are 2 papers that look at sort of fate and transport of atrazine in aquatic systems. And I'm pretty sure it's here in Charleston. But it's not, I mean, it's used here, but South Carolina is not a big state for, it's not a big corn state. So it's not heavy. It's used on golf courses also. So maybe, you guys play golf? Biggest pesticide use, bigger than any agriculture is golf courses.
President of the college is working on handicap.
Sorry? No. It's, I can't tell you what the numbers are, it's much bigger.
Excuse me, it was golf.
I understand. Golf courses are much bigger than agriculture use for pesticides and insects and fungicides. Because they're constantly watering the grass, they don't want the mold, the insect mold. Yes?
The atrazine is one of the leading causes for like biologist and specific species.
showed you a slide from a paper that I wrote called The Cause of Amphibian Decline, and it was meant to be sarcastic. I don't think there's a single cause. I think the single biggest cause of species loss is habitat loss. I think, there's no denying that. But now when you couple that, so now you have habitat loss, right? So now you look at my frogs in an agricultural area. The only water and habitat that's available now is what's coming off of the farms. So now on top of that, you've got introduced species carrying new pathogens, you've got global climate change, and you've got pesticides. And I think the problem is, what we try to show in the paper, that there's such a synergistic interaction between those ultimate causes that you can't say, oh, pesticides killed them, or oh, it's climate change, or oh, the pond dried up, or oh, this disease killed them. All those things are interactive. Atrazine, I think, is more significant for a couple of reasons. One is it's a long-lived molecule, so you're very likely to be exposed to it over and over again. Two is it's very heavily used. It's the most common contaminant of groundwater, surface water, drinking water, rainwater, you name it. So I think it's significant that way. I don't think it's the only one. It's probably not even the worst one. But the best thing about it is we know a lot about it. That, Roundup, maybe 2 more chemicals. After that, you go on PubMed, we know nothing about most of the other 80,000 chemicals. And there's and that's hard to sort. I mean, we've done some papers on mixtures and synergisms, but then trying to figure out which chemical in it, what types of combinations. But there's no doubt in my mind